We're looking at number 5 from the antiderivative word problems worksheet. It says the amount of water in a storage tank is modeled by a continuous function on the time interval from 0 to 7, where t is measured in hours. In this model, the rates are given as follows. The rate at which water enters the tank is given by f of t. So water entering into the tank is given by this smooth curve here, and we see that the rate of which water is entering into the tank is increasing as time as time goes on. Okay, from 0 to 7. The rate at which water leaves the tank is given by g of t, but the rate is going to be at a constant flow. So 250 gallons per hour between the first 0 to 3 hours, but then right at 3 hours, the tank, the rate at which water is leaving the tank is going to suddenly increase from 250 to 2,000, but it's still going to be at a constant rate. So if we think a little bit about what's happening to the water level over the course of this time period, it can kind of help us figure out some important things later on. So if we think about what's happening in this time period, we should also, there's water in the tank to begin with. Okay, it says the graph f and g have intersections at 1.617 and at 5.076. At time t equals 0, the amount of water in the tank is 5,000 gallons. So there's 5,000 gallons to begin with, but then water is being let into the tank, but then water is also being let out of the tank. So if we think about what's happening up until 1.617, water is being let into the tank, but then the rate at which water is leaving the tank is at a higher rate. So what we expect is from 0 to 1.617, we expect the water level to be dropping. Okay? Even though there's water entering into the tank, the water that's leaving is at a higher rate, so water level is going to be dropping. But then as soon as 1.617 hits, to the right of it, the water level keeps, the rate at which water is entering into the tank keeps increasing. So from 1.617 all the way to 3, we expect the water level to start rising again. Right? Water level starting to rise again because the rate at which water is entering is greater than the rate at which water is leaving. But then right at 3, water is being let out suddenly at a much faster rate. And then we expect at 3 the water level to be dropping again because more water is being let out than what's being let into the tank. But then at 5.076, we expect the water level to start rising again, since the curve is going to be higher than this linear 2,000 gallons per hour. Okay, so then part A, how many gallons of water enter into the tank from 0 to 7? So from 0 to 7, we can just find the integral of 100t squared sine root t, right? Because this is the rate at which water enters into the tank. So it's just definite integral from 0 to 7 of f of t dt, which is 8264 gallons. We're not concerned about how much water is in the tank. We just want to know how much is entered into the tank during that time, because so basically we ignore the 5,000 that's in the problem for now. Right now we're not concerned about how much water is in the tank. We just care about how much water has entered into the tank. So we accumulate the rate at which water is entering into the tank from 0 to 7 hours. Part B, find the time interval in which the amount of water is decreasing. So we just talked through this, we expect the water to be decreasing from 0 to 1.617 because we see the rate at which water is leaving is higher. And then also again from 3 to 5.076 because the rate at which water is decreasing is greater than the rate at which water is coming in. So the water level is decreasing from 0 to 1.617 and then from 3 to 5.76 since g of t is greater than f of t. So the rate at which water is leaving is greater than the rate at which water is entering. Part C. At what time is water in the tank the greatest? So we're trying to find absolute max. So if we want to find absolute max, this goes back to extreme value theorem, where we have to test the amount of water at 0, the amount of water at the endpoint 7 hours, and also the amount of water at critical points. The critical points that we're dealing with will be relative max. So relative max is going to be at a point where the rate of which the water is increasing or water is being let into the park is greater than the water decreasing, hitting a critical point. So we're going to see that happen right at 3, because right at 3 is going to be a relative max, where the amount of water is going to increase up to a certain amount, and then from there it's going to start decreasing. Okay, and then we're also to test 7 as well. So we test 7, we test 3, and then we test 0. We don't need to test 1.617 or 5.076 because these are not going to be relative maximums. So this is going to be at a point right when, right after there have been water being let out. So because water is being let out up to that point, we know that's not going to be a relative max. And same thing here, will not be a relative max, only at 3. So we should need to figure out how much water is in the tank at 0, 3, and at 7 hours. So at 3 hours, it'll just be 5,000. Well, we know, first off, at 0, it will be 5,000 gallons. At 3 hours, it'll be 5,000 gallons, that's the initial, plus the amount entering in from 0 to 7, subtracted by the amount that's left the tank from 0 to 3. Sorry, this should be 3, not 7. So the amount of water that has entered into the tank, we just find the integral from f of t. The amount of water that's left the tank from 0 to 3 is just that rate. So the definite integral from 0 to 3 is 250. And then we subtract those, and then we add the 5,000, we get 5126. At 7 hours, 7 hours is, we can think of it as however is in the tank at 3 hours, and then we accumulate the rate at which water is entering in from 3 to 7 hours, and then we subtract the rate at which water is leaving the tank from 3 to 7 hours. And then we just plug this in our calculator. In our calculator, we combine those, and then we add it to how much water was in the tank at 3 hours, and then we get 4513. So comparing these three, the absolute max will have to be at 5126.